Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we would be starting with a new chapter, that is pair of linear equations in two variables. Our agenda for today would be knowing the substitution method to solve the pair of linear equations in two variables, and after that we would be solving one problem using the substitution method. So let's start. Now, when I say that we have a pair of two linear equations a pair of linear equations in two variables, what does that mean? First of all, it's a pair, meaning we would be having two equations, and they say that those equations are basically linear equations in two variables, meaning the highest power of the variables that are there in those equations would be maximum 1. And they are saying that these are the linear equations, that is the power of the variables would be 1, and these are linear equations in two variables. It means that there would be two variables involved in it. So if you want to know the general representation of such linear equations in two variables, it would be of the form ax plus by equals to c. So the general representation of any linear equation in two variables is ax plus by equals to c. Now here if you see, it's an equation because we have equality sign with two different expressions on either side of the equal to sign. Apart from that, we have two variables x and y whose maximum or highest degree or highest power of these variables is 1. Hence they are linear variables. And there are two variables basically. So there are two variables whose highest power is 1, and that is why such type of equations are called as linear equations in two variables. Here a, b, c are constants, so they can be any real numbers. Now, in order to solve, when I say that you are supposed to solve any equation, the statement or the phrase only, like solving any equation, it means that getting the values of the variables that are involved in that equation. We all know that equation is a statement, is a mathematical statement which consists of variables. It consists of different numbers which are combined using different mathematical operations like addition, multiplication, subtraction and division. So when anybody asks you to solve a given equation, it means that you're supposed to get the values of the variables that are involved in it. Now when you have linear equation in one variable, that is equation of the form ax plus c equals to 0. Let's say this is the equation. It's a linear equation and it's a linear equation in one variable. So here if you see, you just need to find the value of x, which can be easily calculated by shifting all the other terms on the right hand side of the equation and isolating the variable x, thereby getting the value of x. So whenever you have linear equation in one variable, you just need one equation to solve the equation. You just need one equation in order to solve the equation. Now here if you see, there are two variables involved in this case, and that is why we would be needing two equations in order to get the values of x and y. So that is why the name pair of linear equations in two variables, because here whatever we would be doing, we would be needing pair of linear equations, meaning you would be needing two linear equations such that when you solve those linear equations, you're going to get the values of the variables that are involved in it. So whenever the question comes that solve the given set of linear equations in two variables, you would always be given two linear equations, and hence the name pair of linear equations. Now in order to solve these type of linear equations in two variables, there are different methods. So we have the geometrical method and we have the algebraic method. We would be studying the algebraic method to solve the pair of linear equations. Now under algebraic method also, we have two different methods in order to solve such linear equations. Let me write one more. So let's say dx plus ef equals to z. Okay, so this is the general representation of any linear equation in two variables. So we have these two pair of linear equations, this pair of linear equations, and in order to solve this linear equation, there are two methods. The first method is the substitution method and the second method is the elimination method. In today's class, in today's video, we would be learning the substitution method. Again, if you have referred my previous videos, I have always made it sure that I explain you problems in a step-by-step manner, so that it is very easy for you to remember the general way in which you're supposed to solve any problem. So here also we are going to follow similar approach, wherein we are going to divide the solving process using substitution method in a step-by-step manner. So here if you see, we would be now starting with substitution method. When I'll explain you the entire process, you will understand why the name substitution method and not something else. Okay, so let's start. Now, step 1 over here is, you have this given pair of linear equations. What you're supposed to do is, you're supposed to either isolate your x or y in the first or second equation. So for simplification process, what we would be doing is, we would be always considering the first equation and we would be isolating the variable x. Now always remember the step in this manner: isolate x. So step 1 is isolate x. When you say isolate x, it means that you have to keep x on one side and rest all the other terms, be it variable y or be it any numbers that are there around x or with x. You have to shift all the other terms on the other side of the equation, such that you have to make x alone. Okay, you need to isolate x. So step number 1 is, consider your equation 1 and isolate x. Okay, so whatever equation you will get, now that is nothing but the resultant equation that you are getting. So substitute the resultant value or substitute the resultant equation that you get in other equation to get equation in one variable. What does this mean? It might sound a little overwhelming to you, but in simple terms, once you get some value, or I would say some equation for x from step 1 using the first equation, now what you're supposed to do is take whatever expression you've got for x and put it in the second equation. Now what happens is, in place of x, now you would get something from here, which would be entirely in terms of y. So your equation second, which was originally equation in two variables, get converted into equation in one variable, and that is because you substitute the value of x that was there in step 1, and hence the name substitution, because here we explicitly substitute the value of one variable into the other equation, so that the equation in two variables get converted into equation in one variable. Once the equation gets converted into one variable form, it is very easy to solve because you have already learned it. You again just have to isolate the value of the variable, isolate the variable on one side and shift all the other terms on the other side to get the value of x or y. In this case, we would be getting the value of y. So if you find the value of x over here, you find the expression for x over here you will be getting the value for y. So in step number 2, you would be properly getting the numerical value of y. Once you get the numerical value of y, now you're going to substitute the resultant value. Now when I say resultant value, it means that the value that you have got in the previous step. So substitute the resultant value in step number 1. Step number 1 में आपको कुछ तो equation मिला होगा in terms of y, right? Your x would be equal to something in terms of y. So already now you know what is the value of y. So substitute it in the equation that you have got in step number 1 and get the value of other variable, that is finding the value of x. And finally, you're supposed to verify. Now verification is a very important step in case of finding the solution for the pair of linear equations in two variables. What does verification mean? It means that whatever answer you have got or values you have got for x and y, you're supposed to substitute in both the equations and see whether your LHS comes out to be equal to your RHS. If it comes out to be equal to your RHS, it means that you have done the solution correctly, and hence you can say hence the solution has been verified. But if it doesn't comes out to be correct, it means that you have gone wrong somewhere and you need to recheck your answer and get the correct answer, right? So to sum up what we have done up till now, we have started with the substitution method to find the solution of pair of linear equations in two variables, meaning we are supposed to find the values for x and y, right? So there are 4 steps involved over here. In short, the steps are: step 1 is to isolate x, right? Step 2 is transformation using substitution. So you're going to transform equation in two variables into equation in one variable. And what's the magic for transformation? It is the substitution that we do. That's the magic that's been done. Step number 3 is finding x using the equation 1, right? So whatever value you have got here, in step number 3 you have to substitute in the first step and get the value of x. And step number 4 is verification. So isolation, transformation, again you're going to find the value of x, and finally verification. Again, step number 1 is isolation, step number 2 is transformation, step number 3 is finding the value of x, and step number 4 is verification. So once verification is done, you are done with your problem, and that is what your solution for the problem would be. Now let's start with the solving of the problem. The question says that solve the equation given pair of linear equations in two variables. Now here if you see, the first equation is s minus t equals to 3, which is very much in the standard form, ax plus by equals to c. But if you see the second equation, it is actually in the standard form, but here if you see, we have denominators over here, and instead of dealing with this fraction type of terms, it is better that we simplify it first. So before doing all these steps, we also must ensure that whether the given equations are in standard form or not. If they are not in standard form, is there any scope of simplifying it or not? If yes, do it. Okay, if you can reduce it further, do it. If you can do any kind of simplification, do it. So here if you see, first equation doesn't need any kind of simplification, but second does, and we can do it. So we have, consider s upon 3 plus t upon 2 equals to 6, right? Now since we don't want the denominator, so what we would be doing is we would be taking the LCM, that is we would be multiplying 2 with s, 3 with t, take the LCM and shift the term on the right hand side. So we would be having 2s plus 3t the whole upon 6, because 3 into 2 here in this case is 6. That is equal to 6. Now since we are doing this so that we could get rid of these denominators, so we would be shifting 6 on the other side. So we will get 2s plus 3t equals to 36. So this is our equation number 2 and this is our equation number 1. So now the pair of linear equations in two variables become, therefore, the given pair of equations are s minus t equals to 3, 2s plus 3t equals to 36. So this is where you are going to simplify your question if possible. If the linear equations given to you are in the simplified form, there is no need of any kind of simplification, and if you are comfortable solving those, then there is no need of doing this step. Now let's start with step number 1. What is step number 1? We won't be remembering this big statements. You pay attention over here. Step number 1 is isolate x. Now here instead of x we have s and t. Okay, so we are going to isolate s. So consider the first equation, which is s minus t equals to 3. We want to isolate s. When I say isolate s, meaning keep s on one side and rest all the other terms on the other side. So s would be equal to 3 plus t, because when t goes on the other side, minus gets converted into plus. So now this is your end of step 1, wherein you got the value of s. Now step number 2 says transformation. Now how does this transformation occur? What magic you need? You need the magic of substitution. So what you're supposed to do it, name this as equation number 3, and now you're going to perform the magic. So you're going to say substitute 3 in, already you have used equation 1. Now it's time to use equation 2. So step number 2, use equation 2. So substitute 3 in equation 2. So when I say substitute 3 in equation 2, it means that wherever there is s, you're going to write 3 plus t. So first of all, write your equation 2, which is 2s plus 3t equals to 36. Now wherever there is s, put 3 plus t. So 2 into, instead of s, now I would be writing 3 plus t plus 3t equals to 36. Now open the brackets over here. When you open the bracket, 2 gets multiplied with both of them. So what we get is 2 into 3, which is 6, plus 2 into t is 2t plus 3t equals to 36. Now 2t plus 3t, these are like terms and like terms get added in algebra. So 2, 3 plus 3t is 5t. So the resultant equation that we get is 6 plus 5t equals to 36. So therefore, you move 6 on the other side. Now, see, step number 2 says you have to transform equation in 2 variables into equation in 1 variable. Did we complete our step number 2? Yes. If you see, this is completely an equation in 1 variable. Earlier, we had this. At the start of step number 2, we had an equation which had 2 variables. But now when we reached to the end of step number 2, we transformed this equation in 2 variables into equation in 1 variable. And how did we do that? We did that using the substitution method, right? So now once you have got equation in 1 variable, step number 3 is to find x using 1. That is, I'm so sorry, it should be find, let it be. So here if you see, once you have got equation in 1 variable, what you're now supposed to do is, you're supposed to isolate the variable that is left in the equation. So you have to isolate t, meaning you have to send all the other terms on the other side. So first I'll send 6 on the other side. So that would be 36 minus 6. So 5t would be equal to 30. Therefore, your t would be equal to 30 upon 5, which implies that t equals to 6. So, your step number 2 says you are supposed to transform equation in 2 variables into equation in 1 variable, and once you get equation in 1 variable, you get the value of x or you get the value of y, whatever you have taken first. So here if you see, since we used the s value and we substituted in equation 2, now we have got the value of t. This is the end of step number 2. Now step number 3 is finding the value of first variable using this equation. So now step number 3 is substitute t equals to 6 in equation 1. So now what you're supposed to do is, whatever value of t you have got in step number 2, you have to substitute it in the equation that you have got after completion of step number 1. So write the equation again. S is equals to 3 plus t. Wherever there is t, you're going to write 6. So s is equals to 9, and this is your end of step number 3. Now once you have got the values of s and t, now you're supposed to verify. So this is a very important step of verification. You're not supposed to write this in exam. I'm writing it for your understanding. So in order to verify, what you're supposed to do is consider the LHS of the first equation, which is s minus t, which is equal to, now substitute the value for s, which is 9, and the value for t, which is 6, which is equal to 3. Or you can write consider, what you can do is, consider LHS equals to s minus t. So that's equal to 9 minus 6, which is equal to 3, and this is equal to your RHS. Therefore, LHS is equals to RHS. So you considered the first equation ka LHS, which was s minus t. You substituted the values for s and t, and you got the answer to be equal to 3. If you see your first equation, the right hand side of it is 3, and hence you can say ki that's equal to your RHS, and hence your left hand side is equal to your right hand side. Still your solution is not verified. Now we have to do the same thing for the second equation as well. So consider LHS as, now you can take this equation. Okay, you can take either this or this, but since we don't want those fraction terms involved, that is why I'm taking this. But even if you take this equation, there is no problem. So we have 2s plus 3t. Okay, now wherever there is s, you're going to substitute 9, and wherever there is t, you're going to substitute 6. So 2 into 9 plus 3 into 6. 18 plus 18, and that is equal to 36, because 2 into 9 is 18, 3 into 6 is 18, 18 plus 18 is 36, and that is equal to your RHS, because here if you see 2s plus 3t equals to 36. If you're 36 is your RHS, and that is what we have got after putting the values of s and t in this equation. If you want, you can substitute them in this equation as well, and you would see you will get the answer as 6 only. So here you would again conclude that your LHS is equal to RHS, and hence you can say verified. And how you are going to conclude the answer? I would be writing the conclusion over here. So you can say, therefore, the solution to the given pair of equations is s equals to 9 and t equals to 6. I would once again explain you quickly what we have done. We have been given the pair of linear equations in two variables. We are asked to solve them, meaning we are supposed to find the values of x and y, or s and t, the variables that are involved here. So first what I did is I tried to simplify the equation number 2. So I tried simplifying this equation. So I got it. I got the equation as 2s plus 3t equals to 36. Now from here your formal procedure for substitution method starts. In step number 1, you're supposed to isolate the value of the first variable. So I isolated s and I got s to be equal to 3 plus t. So this is your end of step 1. After that, you're supposed to do the magic of substitution in order to transform your equation in two variables into equation in one variable. So here earlier we had s and t. Now it got transformed into just an equation which has just t in it. Okay, and how did we do that? By substituting this value into this equation. In step number 2, since it's step number 2, we are going to use equation number 2. And after that, you're going to solve and get the value of the second variable. So in step number 2, you're going to use equation number 2 and you're going to get the value for second variable only. So everything related to 2, 2, 2. After that, you're going to substitute this t equals to 6 or the value of the second variable into this equation to get the value of the first variable. And once you have got the first variable ka value, you have to just do the verification whether your LHS is equal to your RHS or not. So right from isolation, transformation, finding the value of the first variable, and then doing the verification. These are the 4 steps that are involved in the substitution method. And we also understood exactly why this method is called as substitution method. So students, with this we come to the end of today's class, and before winding up, I would just want to tell you that we have completed the agenda for today. That is, we did see what is substitution method and we solved a problem using substitution method. In the next video, we would be solving more problems using substitution method. So do visit the channel. Thank you so much for staying with me till the end of this video. Thank you.